algorithmic state machine charts, or ASM charts. They're just a different visual representation of finite state machines. We have seen finite state machines represented graphically as using state diagrams. So as it turns out, that ASM charts are, or might be, a little bit easier for us as humans to read because they represent something similar to flowcharts. So let's see the basic building blocks of ASM charts and how can we write finite state machines using them, or how can we represent finite state machines using them. So the basic building block of an ASM chart is the following. What you have is something what we call an ASM block. Okay, and an ASM chart is constructed by concatenating or connecting a bunch of these ASM blocks together to form a fully fledged flowchart for that matter. So each one of the ASM block, you're going to have one single state because each ASM block is associated with a single state. So you can see, actually you can put the state name in here. Okay, sometimes some people put the state name inside the state box. Okay, and there should be one state box per ASM block. Okay, and after that, basically, you do have one entry to the ASM block. So because we're representing it as similar to flowchart, so you should have one entry to it, and that entry goes to here. And that tells me that I am in this current state, for example, S0 or S1 or whatever you call it. The state box would have it. And because we might have more outputs, so what you do is you put the more output here in that state, because remember, a more is only changed by the state change, not by the input. So you put the more output in here. Okay, afterwards what you do, you have something we call a decision box. So the decision box, it tells you, and you might have multiple of these decision boxes. It tells you how should you proceed afterwards. Basically, what's your next state, or where should you go from there. So you have a bunch of Boolean conditions, and they could be true, they could be false, and if it's false, you might get another question, or even if it's true, you might get another question, which is another conditional box, and so forth. And if you have mealy output, what you're going to see is per this conditional or Boolean conditional, you're going to see something what we call a conditional output box. And this is where you put your mealy, because your mealy depends on not only the current state, but also the input. And the input usually is embedded in these conditional Boolean conditional statements. And after you follow a certain path from the entry to the output, you're going to see, well, let's exit to another ASM block, or it could be completely another ASM block based on the conditions. All right, so let's see an example. So here's an example of a finite state machine. Okay, and this is actually it's not a whole machine, it's just a single ASM block. So in here, what you're going to see is we have one entrance path, and within that entrance path, it's actually for state S1. And you can see in here, I only have one state box, and that's the only one in this ASM block. That tells me I am currently in S1. And this particular state machines, or this particular ASM block, have a couple of outputs, Z1 and Z2, asserted. And these are more outputs because they only are related to S1. It doesn't matter what the input is. And from there, what I have is I have a conditional or decision box. And that decision box is asking me, is X1 asserted or not asserted? If it is asserted, you go that way. If it's not asserted, you go this way. And as it turns out, if it's asserted, for example, I'm getting another conditional box here, or decision box, and it's asking me, is X3 asserted or not? For example, if it's asserted, you do certain things, it's not complete in here, but if it's not asserted, well, you do have here what we call a conditional output box, and that is a mealy output. And the mealy output in here is Z5, you're asserting Z5. So Z5 will only be asserted if you currently are in S1, and it just happened to be that X1 is asserted and X3 have been asserted, both of them. Okay, they depend on the inputs. And then from there you go to whatever path in here. So whatever you tell me doing here is actually, I follow the path, or what would they call a link path. Okay, this is from the input to a certain output. And you might have through an ASM block, you might have different ones. For example, I might have something like that in here. And these are very similar. So the Z3 and Z4 are basically, they tell me when you are in S3 and X1 has been not asserted, deasserted because it has to be 0, Z3 and Z4 will be asserted and they will be set to 1. And that's basically how we use an ASM block in general. So as it turns out, then ASM block, there isn't a single way to write an ASM block. You can actually redraw it in different ways. So what you see in front of you is actually the same ASM block, we just drew it differently. And the difference is, in here I'm asking if X1 is asserted before I ask about X2, and in here what I'm doing is I'm asking if X2 is asserted before I ask for X1. And the output and the answer is exactly the same. What I have is I have a single path in, or a single point of entry, and I have a couple of points of outputs in here. One will take me to state S2 and one will take me to S3. So this one here, the S2 and then the S3 are basically in a completely different ASM block. And if you can see it like here, what it's doing, if it's X2 is 0 and X1 is 1, this is basically when you end up in S2. And again, if X1 is 1 and X2 is 0, I'm going to end up with S2. It's pretty much the same exact path. Okay, so there isn't a single way to represent an ASM block. There are multiple of them. Some might be a little bit easier than the others to represent or read. Okay. All right, so a few things that you should know, that basically you should never have feedback within the ASM block itself. So this should be an output, and if you wanted to go back to the same ASM block, you just basically take it from the outside. So you shouldn't do this here. This is not acceptable. Okay, something to keep in mind. No internal feedback are allowed, okay? Only external. All right. So what I want you to do here is I want you to pause the video a little bit, and I want you to take this ASM or this FSM here, okay, this finite state machine. This is a state diagram, and what happens to be is an ASM block is just a different representation of finite state machine, and a finite state machine could be basically represented as using a state diagram or an ASM chart. So what I want you to do is I want you to pause the video and take this ASM or this finite state machine or state diagram and actually convert it to an ASM chart. And what I did in here is I gave you the basic building block of a single ASM chart. So if you see it in here, I have 1, 2, and 3 states. That means I need 3 of these ASM blocks in here. So you need to replicate it that way. All right, so I'm hoping you got the time to actually do this by hand. And just as a representation, or the solution should look something like that. So what you can see is I'm just going to go through one of the ASM blocks, and let's go through the ASM blocks for the state S0. So what you can see in here is S0 tells me I have a more output, and that more output Y1 equals 1. And what you can see here is basically tells me if you are in S3, Y1 equals 1. You can write it as Y1 equals 1 or just Y1. It's up to you. Okay. And here what's it telling me is what you need to do is you need to ask, is A asserted or not asserted? Because I just want to know, should I come back here or should I actually go back here or here, basically when it's asserted, when A is 1. This is A1, this is A1, and this is A not. So in here I'm asking, is A equals 1? If it's not, I can't come back in here because that will be internal. So what I need to do is I need to get out of the FSM block or the ASM block and then back in here. All right. However, if it has been asserted, then I get to have the question, is B asserted or not? So, well, if it's true, I'm going to ask, is B asserted or not? So if it just happens, if B is asserted, I'm going to go to S2. So if B is asserted, which is here, I'm going to S2. But what happened is I have a mealy output in here, and that's why I actually put the Y0 equals 1 in here within the conditional or the conditioning output, okay, the conditional output box. So the same goes in here. You can see that if A is asserted but B is not asserted, I'm actually going to S1, and that's exactly what happened. And you can follow the rest of them as well. It's basically the ASM chart. So these two representations represent the same exact finite state machine. This one here resembles a flow chart, so it might be easier for us as humans to follow.